Welcome to Pavithra Laptop Care. Today's topic is clock. What is clock and where we are using? So totally we will discuss today in the motherboard laptop. Okay, see, clock is nothing but digital sinusoidal waveform. Okay, it's a digital sinusoidal waveform, nothing but pulse. We call it as pulse. Pulse looks like this. See, you have seen these pulses, right, in laptop service. Here, this one is called high and this one is called low. In digital waveform, it looks like this. Here, this upper portion is called is a high, and this upper portion is called lower portion is called low. Okay, total from year to year is called a cycle. Okay, from year to year we call it as a cycle. See, year to year and year to year we call it as a time delay. This one is complete cycle, and year to year we call it as a time, the time duration. So we measured it in hertz, so we call it as a frequency that measured in hertz, means per second. This pulse per second, how many pulses will move, that's called frequency. Now you got my point, right? What is the frequency? Frequency is nothing but 1 divided by seconds, means per second how many cycles will move, that's called, it's a frequency. We measured in hertz. Okay, you got my point, right? Once again, so I'll delete this, so I'll write it down once again. See, this is called pulse. Okay, here this portion we call leading edge. What? Leading edge. And this portion we call it as falling edge. This one is leading edge and this one is falling edge. This one total time delay. Okay, see, in machine language we know the machine can understand only 0 and 1. That's called 0 and 1 is the machine language. To carry the signal, these frequencies will be using to carry the signals. Usually to carry the signal, number one. Why these clocks are using? These clocks are using for carry the data, carry the information, data. And second one, to make it as a high-low concept. So on and off concept, it will be used in on and off pulse generation or frequency generation or voltage generation purpose. This one I'll tell you where we are using this application, and this one also where we are using. Just I am giving a information. This one is carry the data and second one is on and off purpose. The electronic circuits, the IC, it makes on and off. For on and off purpose it will be using. So one by one we will discuss what is that carry data. In laptop what it will be used. See, in any schematic, I will take a schematic. Through the schematic I will explain you See, here is a schematic. Here, what is this? This is a processor. Okay, this one is PCH. This one is PCH. This one is NE IO. I will tell you once again. Here, before that, you must understand the concept of this clock where we have to use. Here is a main device called master device. Okay, we call it as a master, and it is connected with multiple slave multiple devices called slave. Okay, this one is master. See, for example, in machine language, in laptop, this is called for example CPU we will take. Okay, here multiple devices, for example USB, camera, mic, audio. Okay, these all are called slave. How this CPU communicate with these? How? Through the voltage? Definitely no. The voltage is only for supporting purpose, to enable the circuit. Only for activate the circuit we will use the voltage. But main thing should be communicate with this master and slave. Master with the slave and slave with the master. There should be a communicate. See, for example, master is CPU. Just you consider, I am taking as an example, CPU is a master and slave is a USB, camera and mic, audio. See, in laptop motherboard, this in digital software level I am telling, each and every slave will be having a address. For example, 001, 8-digit address will be there. One, this one is 00000002. This one is 0000003. Okay, how it communicate with the master? That is very interesting thing. See, here this one I take it as a 2, and this one is 1, and this one is 3, and this one we consider it as a 4. Okay, all slave will be having unique address that should be noted. Okay, all slave and master should be having unique address. It should not be overlap. Okay, now master is 0000010 something. Just we consider it is a 10 something. Now this master should communicate with this slave. How? See, it will communicate with this. How it will communicate? In which language it will communicate? See, it must communicate with machine language only. Machine language only. It gives a command to particular slave. See, for example, it gives a command to 0000001. First, a signal will pass to all slave. All slave and master should communicate with each other through the signal. That's called clock signals. See, all slave should be having clock signals. Through these signals, this master and slave will be communicate. See, I told you this address it will find a work assigned to this particular unique address slave. First, this communication will detect this is belongs to me or not. If it is belongs to this, then this will work as per the master. Same thing will goes to here. this it will search this unique ID, this is belongs to this slave. If no, a acknowledgement won't go there here. So one acknowledgement will go when this particular slave is okay. See here this one is chosen, right? 4 zeros, 5 0, 6 0, 7 0 and 1, 7 0 1 1, this one will match. Okay, here what it does, so it send a acknowledgement to the master, yeah, I am ready to do work. Okay, then master will send the commands, what are the work is there, that gives to the slave. Then this will work and it returns to the master. So this is called master and slave configuration. First you have to understand this one, master and slave configuration. That one by one I will show you. See here, this one is processor. Processor is connected to EDP, HDMI port and here RAM. Okay, see these all are slave. This RAM, this EDP and HDMI is connected to the processor. Means processor here is a master and this part will be what? Slave. See this processor having a particular megahertz clock. Through that clock it will communicate with each other. Okay, through that clock it will communicate with each other. See this speed 1.2 volts DDR4 2400. Once you connect this RAM, this will communicate with the processor. This one master will communicate with internal or external megahertz crystal. Same as CPU, this one is chipset, right? PCH, platform controller hub. This controller hub is connected to these two SSD, wireless, Bluetooth, LAN, SATA, this one hard disk, USB, Type C, CMOS camera, fingerprint, USB charger. These all are slave. Okay, this one is master. These are communicating with 48 megahertz frequency speed. It has 48 megahertz crystal inside this PCH. Through that crystal, it's communicating with each other. These slaves. This one is master. Now you understand, right? This is the master and slave. What is the master and slave technology? Master and slave will be communicating with each other through the clock signals. And here, see this LPC clock bus. Through 24 megahertz crystal, it's communicating with PCH and TPM devices. This one is connected to touchpad and keyboard. Here is the ROM, SPI ROM. Okay, like this in laptop communication will happen. Laptop won't work through the voltages, not only the voltages. Voltage is only for activate the particular device. See these are particular device, it will activate. But in smart technology, this IO, PCH and processor will work through the signals, through this clock. Now you understood what is that master and what is that slave. Master will be 1 or 2 or 3, but slave will be multiple. Okay, now I already explained you. Number 1, this one is for communicating or carrying the data. This pulse will be using for carrying the data. Okay, how it will carry that in a schematic I will explain. See now, page number, just a minute, where maybe 6, I think so. No. Here I will search a charger. See, here is the main example for master and slave. See, here is the PCH is the master. This master is communicating with SM clock and SM data through this pull-up voltages. Through this pull-up supporting voltages, these signals are moving to QS7 and SODIM. SODIM, it's a RAM section. Okay, here is the best example for clock and data. Clock and data. Through this clock, this data is transferring. See, data means it's a 1 and 0, 0 and 1s, right? This clock, how it works, see, this is the clock. Here the 1 data will carry and here 0 data will carry to the destination part, slave or master. Here master or slave. Okay, this is the best example for clock. Now see, this IO SMB clock 1 and SMB clock data 1 is communicating with battery connectors. When you put the battery will be communicating with IO through this SMB clock 1 and data 1 signals. See this charger IC. This charger IC also communicating with the keyboard IO IC. Keyboard IC means IO. It means SDA SCL. You already heard the word SDA SCL. That is be there in charging IC. Okay. Through these signals, battery will work and charger will work. See, SMB clock 2 and SMB data 2. Through this, thermal sensor will work. Okay. Next, clock 3 and data 3. Here LED drivers will work. So now you got my point, right? Where the clocks are using. In laptop, voltages are not major. We are not considering only voltages. Voltage is not 100% important. That's only 10% important. Only 10%. You need to give concentration on voltages only for 10%. 90% you need to concentrate on these. Without these signals, this won't work. See, this is the slaves and this is the master. Each communication should happen, then only this particular section will work. For example, hard disk has to work. For hard disk, this particular PCH signal has to go, then only hard disk will work. Okay. Now, in second example I told. In second example, what the given the second example? This pulse will activate the MOSFETs. Switching MOSFETs we call. This one is high MOSFET and this one is low MOSFET. Here is the gate control. Gate control will provided by the IC. This IC passes the pulse. Okay, this up to what frequency it will pass till the time. See, year to year till the time this will be in high, means on. Okay, when it reaches here it will be in off condition. Same kind of this is called upper gate and this one is called lower gate. Okay, in any IC, any PWM IC, pulse width modulation IC, upper gate and lower gate is the must. These gates will produce us these pulses nothing but clock. Through this clock it will communicate with high MOSFET gate. This one is communicate with low MOSFET gate for switching purpose. See, I told this one is high and low concept. This one is high time. The particular time it will be in on condition and particular time it will be in off condition. Like this it will generate a unknown pulses and it will finally convert as a pure DC through the coil. Coil voltages you already know. What are the coil voltages? 3.5 battery voltages, 3.5 voltages, RAM 1.8, so many are there, V core, many are there. Okay. This one is best example in schematic. Let us check. Hmm? This one is maybe in page 83. See, this one is charging section. Just now I explained. Here is high MOSFET and here is the low MOSFET. This one is communicating with this particular IC upper gate. See, upper gate is connected to the gate. Lower gate is connected to the lower MOSFET. Here, if you check through the multimeter, you won't get the voltage. 100% you won't get the voltage. Maybe 0 or 1, maybe some unknown voltages you will get, but 100% you won't get, because this one is pulse. Pulse is a AC form, not DC. Finally it converts as an unknown waveform and finally it will convert to DC. Example 3.3 volts, 5 volts, 1.2, like that. See, here it's a battery voltages. Through this coil, battery voltages is producing through these switching MOSFETs. Switching MOSFET is controlled by this IC through the cycles, through the clocks. Okay, one more example. If you come down, this one is 3 volts always. 3 volts always. It has inbuilt high-low MOSFETs. So final output you will get in PL301 pure DC. Here unknown AC. Here inside 2 MOSFETs will be there. That one produces what? High-low MOSFETs gates. Through that gate it will produce unknown AC. Finally pure DC will come. See, this one is 5 volts and this one is RAM. See, here RAM IC, it has given low gate and high gate separately. Upper gate and lower gate. See, upper gate is connected to the high MOSFET gate and lower gate is connected to the low MOSFET gate. Finally it produces the output DC. See, 1.2. This you must, you have to know. Okay, if you don't know about this clock, definitely you can't service the laptop. You won't service the laptop. Only mucky service only you will be doing till the end. How many years you spend? Till that end you will be doing only mucky service. So this knowledge should be 100% required. What is that? Clock. Now you understood what it does. So one thing is it carries data. Second one is switching concept. In switching concept it will be using. Okay, main thing is the clock will be generated by crystals in laptop. Okay, now you got my point, I think so. Now you understood what is that clock and what is the use of clocks in schematics. Okay, that's it. Thank you very much.